So we talk about uniform distribution. Now we generate random variables follow uniform distribution. For this one, the minimum is 0, maximum 20. So we generate, use this way. And then we generate 2,000 of them. So this is 1,000. I just copy paste. See, this is, so it should be until 2001. I put a mark here. That will be easy for me to generate another one. Excuse me. Now I generate another one between 5 and 30. So how we can do this?
Could you multiply it by 25, add 5?
Yeah, awesome. That's what I'm going to do. Awesome. You generate the random. Okay. So in other words, you can shift a little bit. We can generate something like this, right? And then we just move the whole thing at the A, so we can generate in Excel. Awesome. So for PC, if you double click, it will match copy the formula, but the length will match the adjacent column. So we generate another. Yeah, this just for the copy paste purpose. This is the end of my data. So delete this one. So now we generate the random variables follow uniform distribution. Okay. So next thing, for any distribution, we like to know where's the center, how it is spread out, right? So for this one, where is the center? Yes, B. The center is here, right? So not just the B minus A, that's the range, right? So the center is here. So you can see from the graph, it's like this is half of B minus A. And this is A plus half of B minus A. So that's equal to half of A plus B. So this is the variance, half of A plus B. Yeah, I try to make more sense. It's like, this is the range. Range is B minus A, right? This is a half of the range. And this is, see, my axis is A plus, right? This is the mean. So you add together, that's A plus B. Make sense? So here is where is my mean. So what's the median? What's the median for uniform distribution? Median and mean, are they the same? Yes, because it's a rectangle, it's symmetric. So mean and median are the same for uniform distribution. So since we have this density function, so you can find out the variance distribution. It's just a sample. And now how about the U, or just the U1 plus U2? Okay. Does it still follow uniform distribution, or what's the mean, what's the standard deviation? So because we like to explore the linear combination, see we can test this is first one plus second one. Okay. So for the PC, that's easy. You double click, automatically fill in the forms. So this is mu1 plus mu2. And then we can find out what's the mean, what's the standard deviation. So we call sample mean, or sample variance. Okay. So this is sample mean, we can use average, right? From A2 to A2001. And the variance, that's we use that as just the sample variance from A2 to A2001. Okay. So we can do the same. Question?
You should.
The mean, we just use average. So the next column just average from B2 to B2001. And then we have the sample variance. And also we have we know we hold, or we can see the population. Population mean and population. Population variance. So this population, that's the stereotypical because we generate from this distribution. So the population means just the whole distribution, right? So we know when we generate for first one, randomly between 0 and 20, where's the mean? Anyone? That's halfway, A plus B, right? So that's 10. Or you can see equal to 0, A plus B divided by 2. Okay. So for this one, we know the random between 5 and 30, so the mean will be equal to 5 plus 30 divided by 2. Make sense? So you look at, so we generate, because the sample size is big enough for 2,000, so it's quite close. The sample mean and the population mean is quite close. Okay. The variance, we look at the formula here, that's b minus 1 squared divided by 12. So you don't need to memorize, so we will give you the formula during the test. So for the first one, b minus a, that's 20 minus 0, right? Squared divided by 12. So it's quite close, right? The variance, the population one, stereotypical calculated versus the sample of 2,000. And this one, that's b minus a squared divided by 12. Okay. It's also quite close. Now, what's your finding here? Question? Oh, that's just the formula here. Yeah. This formula, certainly you can use the density function. The variance is x minus a little bit more. How to get here, the formula. So for this one, we know that's from A to B. And each value, x, how far away from the mean, right? And then squared. And then multiply by density function, f of x. So you solve the integral, you will find out. Yeah, sometimes that 12 sounds very odd, right? This is how it find out. Now, what's your finding from here? Because we did simulation, right? We tried 2,000 experiments. Okay. So 2 random variables follow uniform distribution, just totally random. So two variables add together, the result variable. The mean, it seems like still you add two mean together, right? Makes sense? It's quite close, right? And this one add together 83 point, it's around 84 point something. So this is true because the linear combination, no matter what the population plus y. So theoretically, this is equal to your first one's mean plus second one's mean. So you see this is quite close, right? So the variance, there is one condition. It should be pay attention. So this is about the mean. You can do still linear combination no matter what type of distribution this random variable from. But for the variance, we should be independent. If they are independent random variables, and then the variance you can add together. So we can generate select data to see what's the histogram look like, right? We insert a histogram. So do you think it still follow uniform distribution? Yes or no? So uniform, the histogram will look like a rectangle, right? We look at this one. So this, I just give a title. This is mu1 plus mu2. No, uniform u1 plus u2. Okay. So how about, see what is u1? See, this is U1, the uniform distribution from 0 to 30. Okay. Not 0 to 30. To what? To 20. To 20. Okay, thank you. 0 to 20. Oh, whoops. 0 to 20. Okay. So you look at this one. So this is uniform. That means the chances or the frequency is equally likely. It's almost the same for each time, each interval. Okay? But here, it's like U1 plus U2 is most likely, it's like in the center area, right? Less likely on the edge. So certainly, you add together, it's not uniform anymore.